Alright, we're going to start this chapter off by doing transformations of quadratic equations. So here we have our original equation of y equals x squared. So our graph would have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So what does this right here do? Does it change x or y? You should say that the 2 is going to multiply y by 2, and you should say that 3 is going to subtract from the y as well. X does not change because there's no parentheses in there. So x is negative 2, negative 1, 0, 1, and 2. Y becomes 8 minus 3 is 5. And 2 minus 3 is negative 1. 0 minus 3 is negative 3. 2 minus 3 is negative 1. And 8 minus 3 is 5. And so there would be our graph. And I'm going to trust that you guys can plot those points, so I'm not going to go ahead and put those on a graph. Alright, so we're going to do the same thing here. So on your own, see if you can do the original in out table and the new in out table for negative 2x squared minus 2. You should get negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Your new in out table, hopefully you have paused the video, so now you're replaying to see if you did it right. You should multiply y by negative 2 and subtract 2. So x all stays the same. And y becomes negative 10, negative 4, negative 2, negative 4, negative 10. And you are done. Alright, so we're going to start with the same original in out table here. And some things have changed. We now have this x term. Well, when we do transformations, we never have more than one x. So what we get the pleasure of doing, yay, is putting this in vertex form, where it looks like a times the quantity x minus h squared plus k. You have done this for your project back in the second 9 weeks. You also did this with circles. So our original in out table is the same. So I'm going to go ahead and get that written on my board. The new in out table, we have to modify this. So what we're going to do is we're going to complete an area model. It has to be a perfect square, and we want it to be negative 6x. So if it's a perfect square, we want negative 3x and negative 3x, which make 9. If you multiply them. So our area model shows x minus 3 squared. In our area model, we have x squared minus 6x plus 9. So yay, we got the x squareds match. We have our negative 6x's match. However, our 9 and our negative 1 don't. So we have to find the difference in the constants, which the difference in our constants is to subtract 10. So our form for this is x minus 3 quantity squared minus 10. So now for transformations, what does the x minus 3 do inside the parentheses? You should say you add 3 to x, and then minus 10 on the outside, you subtract 10 from y. So our x's become 1, 2, 3, 4, 5. Our y's become negative 6, negative 9, negative 10, negative 9, and negative 6. Alright, so let's try and put this one, since it has an x, we have to put it into vertex form. So this one works a little differently because there is a 2/3 out there. The 2/3 can't go in our area model because it has to be a perfect box and it has to be x minus h. So we got x and x still. So we take out 2/3. So what we're going to be doing is multiplying this whole thing by 2/3. So what I'm going to do is I'm going to take my linear term of 4/3 x and I'm going to divide it by my a value of 2/3. When I do that, I believe you get 2. So let's make sure. 4/3 divided by 2/3 is 2. So we got 2x here. So I want 2x for both my boxes combined, not each individual box to be 2x, but combined. So I'm going to have 1x and 1x, so plus 1, plus 1. So I get 1 there. So what my area model shows is x squared plus 2x plus 1. So if I distribute my 2/3, I get 2/3 x squared plus 4/3 x. Yes, that all matches. Plus 2/3. That does not. So we have to find the difference in our constants, which is -1 and 2/3. You subtract you take the original minus the new. And so our vertex form looks like y equals 2/3 x plus 1 quantity squared minus 1 and 2/3. So our original and out table is still that crazy one that we've been doing all along. And our new and out table. The x is going to be subtracting 1. The y you're going to multiply by 2/3 and then subtract 1 and 2/3. So x's become -3, -2, -1, 0, and 1. Y's become 2/3 times 4 minus 1 and 2/3 is 1. And if I take it times 1, I get -1. If I put in 0, -1 and 2/3, and -1 and 1. Okay, so, Gilliam,